guys, what we're going to do today, I'm going to teach you the last bit. It's a bit of a concept, a few words that we need to know about probability, like definitions. And then, if we have time, hopefully we will, I will solve one example from what we learned last lesson. Okay, we went through these examples and I think you need a little bit of help on that. So I'll just remind you what we did last lesson. You can see it. We've got the fundamental theorems of probability, or principle, or formulas, whatever you want to call it. Okay? The probability of a union of A and B, A or B to happen, is basically the probability of A plus the probability of B minus the probability of the intersection A and B. Okay, so we have to minus that. Oli said it correctly because we're counting it twice. If we didn't have that, we're counting it twice. The second thing is about the not A. Okay, the probability of A happening is 1 minus probability of not A. Okay? So when you add these together, A and not A, it has to always happen, add up to 1. Now we're going to go through these words. Okay, so there are words that describe events. Let's start with mutually exclusive. Okay? Mutually exclusive in a formula language means basically P, A, and B are equal to 0. That's, if two events are mutually exclusive, there is no intersection, yes? So they're not touching. So in a Venn diagram scenario, they would look like this. A and B. There is no intersection. Now, for mutually exclusive, only for mutually exclusive events, we can say that PA or B will be equal to PA plus PB. We can just do PA plus PB. We don't need to minus PA and B. Why is that?
Because it's 0.
Because it's 0. Okay? Yeah, we can minus that, but that by definition is 0. There is no intersection, so we're not going to count it twice. Okay, so that's mutually exclusive. Think about exclusive. They're exclusive. They don't mix with each other. Okay? Our opposite one will be inclusive. If we say that events are inclusive, what do you reckon we mean? That they are touching. So it's going to look like this. Okay? There will be an intersection. In other words, PA and B is not equal to 0. Thank you, Pat. Thank you for that. Okay? And that means if we want to calculate the probability of A or B, then we need to minus that. Pretty easy, right? Let's move on to exhaustive. Any guesses what exhaustive means? Language. What does exhaustive? When I say something is very exhaustive, what does it mean? It's tired. It's not exhausted. Yeah, it's true. Like Aaron, yeah. But anything else, Olivia? What is exhaustive? If I don't know if my language is good enough. If I say this essay is your answer is exhaustive, what does it mean? Can you say? It's over the top. It includes everything, isn't it? Is that right, or am I just making it up? Anyway, we'll go with that, right? So, two events are exhaustive if between of them they add up to, or they don't add up to, they include all the possible events, if that makes sense, okay? So we don't have, I can't really use a formula for this, okay? But we'll do a diagram, okay? If this is the sample space, and I've got A and I've got B, there might be an intersection or there might not be an intersection, but let's write all the elements. Let's say in A you have A, B, C, there's a D here, E, and F. And there's nothing outside of them. They are exhaustive. Okay? So I can think, for example, I don't know what, the boys and the girls, and coming back to that, the boys and the girls in this class, these two groups are exhaustive. So everyone belongs to a girl or boy, maybe some belong to both, but there's no aliens here, animals in this class. Okay? So between these two groups, they include everything. Okay? Now complementary. Complementary is a combination of mutually exclusive and exhaustive. If I'm adding those two together, I'm going to get complementary. So how would I draw that? Let's start with drawing it. How would I draw that? mutually exclusive, and exhaustive. So first of all, they mustn't touch. Okay, I've got A, I've got B, okay, and everything in it. Fantastic. So we're going to write, let's say, A, B, C, X, Y, Z, R. There's nothing outside here. Okay, right? It's basically exhaustive and mutually exclusive. What kind of formulas can I write here? What will be the corresponding formulas that characterize it? First of all, I can say that PA and B equal to 0, because if they're complementary, they're obviously mutually exclusive. But there's another one that I can say. What is PA plus PB? 1. It's 1. PA plus PB is 1. Okay? I'm just going to pause here for a second. Okay, so we've got the two formulas. There is no intersection, so PA and B is 0. PA plus PB, they add up to 1. And I'm going to ask you one last thing. What is PA or B going to be equal to? The union of those two.
It's just going to be 1.
It will be 1 again. Okay? So the probability that an item belongs to one of these groups, if they are exhaustive, because complementary events are also exhaustive, then it's going to be 1. Okay? This is not difficult stuff. The difficult part is just to remember it. And I gotta be honest with you, I always have to remind myself as well. Mutually exclusive, just think they're exclusive. They don't want to mix. Inclusive, they do mix. Exhaustive, they exhaust all the possibility. And complementary, just remember that they add up to each other. Okay? Alright? That's it. I'll pause here. We'll do the example a bit later. Right, guys. So, yeah, as I said, I'm going to do an example now. And I think as I'm going through this as well, what I'm realizing, and I think I can see you guys realizing as well, that when we solve problems, we're going to sometimes use the formulas and sometimes the tick method, a combination of the two. Okay? Formulas give you the answer straight away, but you don't know exactly what you're doing. With the tick method, you really can see it. So we're told P is not A is 0.4, PA or B is 0.9, PA and B is 0.2, and the first thing they want us to find is PA and PB. Now here, in this case, there's no point in looking at the diagram just yet. You simply use the formulas. So the probability of getting A is basically 1 minus the probability of not A. Okay? That's this formula. Okay, so the answer straight away is 0.6. Okay? The probability of getting B, how are we going to know that? Well, what I know is that PA or B equal PA plus PB minus PA and B. And I've got all this information except for PB. So I can find out. What is PA or B? Is 0.9. PA, I just calculated, is 0.6. PB, I don't know, so I'm just going to write it like this. Minus PA and B, I know it's 0.2. Okay, is this how you guys did it, or did you do a tick method here? I think it's just like that. I don't know if you can even do it at this point, tick method. So we definitely use the formulas. So what we get is 0.4. We get PB equal 0.5. Is this right? Is that what you guys got?
Yes.
Okay. Then, now comes the next bit. They're asking us PA and not B. Yeah. Now, at this point, I looked at it quite a while and trying to figure out, can I do the formula? I didn't really see it. Maybe it probably is possible, but I think it's quite difficult. So it will often happen that you will start the question using the formula, and then you say, okay, now stop, now I need to draw a diagram. At this point, I already know what PA and PB and the inside, the union and the intersection. So we start from the middle, as always, 0.2. Now I know that PA is 0.6, so that's 0.4. And this is, PB is 0.3, so I'll add together to 0.5. And that means we have 0.1 at the end. So now we're doing the tick method. Let's do colors. I've got colors. We're looking for A, so let's tick A. Tick, tick. And then we're also looking for B, for not B. Okay, what is not B? This is not B. This is not B. This is not B. This is not B. Okay? Now, I've got an AND here. So am I looking for 2 ticks or 1 tick?
One. And then two.
2 ticks, because it has to be both of them. Okay? So the answer is going to be 0, 4. Just bear with me one more second. Okay? Alright, so here we use tick method. Now, check this out. They're asking me, a couple of questions later, they're asking me PA or not B. Now, there's 2 options for you. You can either just do the tick method, but now it's or instead of not. Or here you can use the formula. Okay? Because how do we find or? Okay? We basically add the 2 probability minus the intersection. So I'm going to add PA plus P not B minus the intersection of PA and not B. Okay, just bear with me, guys. Okay? PA I know is 0, 6. Okay? P not B. I don't have it, but a very quick calculation. If PB is 0.5, P not B will be 0.5 as well, because it's 1 minus 0.5. And PA and not B, we just calculated now, is 0, 4. So the answer, that can't be right. No, that should be plus. Okay? 1.1 minus 0, 4, I should get 0, 6. Okay, so again, maybe here we start with formulas, we go to the tick method, and here we can use either. That's how it's going to go. We're going to bounce between the 2. Have a lovely day, guys.